we're leveling off here, so I'm going to go ahead and get started real quick. So my name is Alex Parker. I am a senior product manager here at Replicated. And like Grant alluded to, I'm going to be talking about how to increase installation success with custom host and app preflight checks. So thanks a lot for joining the session, and feel free to ask questions as I'm going along. You can put them in the chat. Fernando's here moderating that, so you can put questions in the chat. You can just, honestly, it's a pretty small group. You can come off mute and just ask a question if you want to. I'm happy to dig more into something if people want to talk more about something, and or I'm talking too low level or too high level. Feel free to help direct this because it's a pretty small group. So pull up the chat here. Cool. All right, let's go ahead and get started. So the goal, obviously, from the title is to try to increase installation success. And we want to do that by ensuring that requirements that are tailored to our application are met before an installation actually occurs. So the solution to that is preflight checks, which is what we're here today to talk about. So we'll start with an introduction to preflight checks. And what exactly is a preflight check? Well, ultimately, it's a check that runs prior to an installation to prevent common errors. So it's going to check for certain requirements and conditions that are present in the environment to ensure that those checks pass or whatever the conditions might be before proceeding to the installation. And in that way, be able to catch common errors and prevent failures from occurring down the line. And they're defined in a YAML manifest. So it's very Kubernetes native in that way. And we'll get to see that, an example of that shortly. So there's two types of preflight checks that we're going to talk about today, and they're used in different situations. So in the first case, we have host preflights. Now these run before Kubernetes is installed. So if you're familiar with Replicated and you're delivering your application to customers who don't yet have Kubernetes installed and they just have a bare metal machine or a virtual machine, and you're installing Kubernetes onto that host first before you're installing your application, host preflights would be relevant there. So before Kubernetes is even installed, these host preflights run. And the goal of them is to ensure that conditions for running Kubernetes, as well as any associated add-ons for storage or networking, things like that, any conditions for any of those components are met on that host before the installation actually proceeds. And on the other hand, you've got application preflights, which have been around for longer, and maybe more people are familiar with these, but these run before your application is installed. This is kind of a core part of the admin console experience, and they ensure that the conditions for running your app are met in the environment. So there's two phases of a preflight check. Just go over these real quick. You've got the collect phase and the analyze phase. The collect phase is first, so I'll mention that first here. The goal of this phase is just to collect all the information that's needed in the cluster that's going to be used later during analysis. So any information that we want to analyze, we have to collect that during the collect phase. And there's a large set of collectors that are included automatically. So you really just have to specify the collectors that you want to add on top of the defaults to customize the information that's going to be collected. But all of this information is collected so that it can then be leveraged in the analyze phase, which is a set of criteria and operations that run against that collected data. And each of these analyzers produces 0 or more outcomes. And then each of these outcomes is either a pass, a warn, or a fail. So looking at this all together, we read in a preflight spec, which we said is just a YAML manifest that defines the collectors that are going to run to collect things like logs and statuses and files and resources in the environment, to collect up all that information and then run the analyzers that we've defined against that collected information to produce our results, which are a series of pass, fail, or warn outcomes that kind of give us an indication of whether this environment meets the requirements that we've defined in these preflight checks for our application or for Kubernetes, depending on what we're installing at the time. So we'll start with app preflight checks. And the goal of these is just to codify our application's requirements so that everything that's needed to run that application successfully can be verified before the application is actually installed. So the great thing about app preflight checks is that codification, that you're able to codify all the stuff in advance. If I know my application needs to hit this endpoint, and it needs this much memory and this much CPU, and I need this storage available, and it needs to be this much utilized and things like that, you can codify all of those requirements into a preflight check to actually run before an initial installation or before an upgrade. to make sure and verify that the application's ready for that installation. So I've mentioned these a little bit, but like you can look for resources like CPU, memory, and storage. You can look at database versions and connections. You can look at HTTP requests and the status codes that they return. You can execute arbitrary commands and use the results of those arbitrary commands to analyze conditions and situations within the environment. And you can do Kubernetes specific stuff like looking for particular resources like a config map or a secret. You can look at the Kubernetes version or the distribution and a whole lot more. And if I've got time at the end, I'll pull up some documentation. We'll just kind of look at the array of things that are available here. But to get a little bit more hands-on, let's jump into a demo of the pre-flight checks here. So I'm in the vendor portal, which hopefully you're familiar with this, but this is like RSaaS for software vendors to create releases and control their application and their releases that they're distributing to customers. And I've got here a pre-flight spec, so we can see, my API version is troubleshoot.sh/v1 beta 2, and my kind is Preflight. And we can see within the spec the two different phases that I mentioned before. We have the collectors, and then beneath that we have the analyzers. So I'll quickly just go over what it is that we have here and what I'm searching for and how this would be useful. So first we have a collector for secrets. So in this case, I'm going to collect a particular secret. That secret should be, is hopefully in the environment with the name my app Postgres. We're going to look within the default namespace for that. And then we're going to check for a particular key inside of that secret called URI. So in the collect phase, we're going to look for that secret, try to collect it. In the analyzer phase, it's a very similar corollary to this. We can name it. This just sort of makes the output more pretty. We'll see that in a little bit within the admin console. Again, just define the secret name and the namespace and the particular key that we're looking for. And in this case, the outcomes are just dependent on whether that secret is present or not. So if it's not, that's going to produce a fail outcome. And we're able to give this a custom message to say, the my app Postgres secret wasn't found, or maybe it was found, but the URI key wasn't detected within that secret. And then if that secret is present within the environment, then we can just message that and say, great, the Postgres URI was found in a secret in the cluster. So that produces a pass outcome. Now I put one more analyzer in here to exemplify something else. You'll notice that I've got a cluster version analyzer here that's going to be looking for the version of Kubernetes in the environment. But you'll notice that there's not a corollary collector up top that corresponds with this one. And that's because the cluster version is just collected as part of that default information that's collected in the environment. So I don't need to specify a particular collector for that. I can just specify this analyzer and my outcomes. So in this case, I want to fail if the Kubernetes version is less than 1.21. So we're only going to support from Kubernetes 1.21 and on. We're going to warn if the version is less than 1.23. So these outcomes work similar to a switch statement if you're familiar with programming. So if we don't hit the first condition, we'll move on to the next condition. So in this case, we weren't less than 121, but we are less than 1.23. So we come right in between those. And in that case, we message that by saying that the cluster meets the minimum version, but we recommend upgrading to 1.23. And then finally, this is sort of like a default. We don't have a when condition on this pass. So if we don't hit any of those other conditions, we pass. And we say that the cluster meets the recommended and required versions of Kubernetes. And you can also include a URI in these. So for instance, if you have a failure outcome, you could link out to say documentation that explains how to overcome this problem. So not only is someone going to be alerted, oh, I have a failure outcome here that I need to address, you can actually provide a link as well right there in the experience, which we'll see in a sec, to link them out to instructions on what they can do to resolve that problem. So I've already gone ahead and deployed the admin console and uploaded my license just for the sake of time to skip over some of that. And we can see here that I've got this new version available and I've got pre-flight checks here. So I'm going to click on these to pull these up. And you notice these are the same two pre-flight checks that I just defined momentarily ago. So we've got the Postgres URI secret, and this one's red. So we can see this actually failed. So the my app Postgres secret wasn't found or the key wasn't detected. And then we've got the required Kubernetes version, which warned. So in this case, we know that I at least had Kubernetes 1.21, but I didn't have Kubernetes 1.23 or later. So I fell in between those. I have 1.22 installed in this environment. So I got a warn. So if I'm an end user, I see this and I've got the warning, but I do meet the minimum version of Kubernetes. So maybe I'm not too worried about that one. I'm going to ignore that. But presumably, this application is going to leverage Postgres. It requires this secret to authenticate with Postgres. So it's important that I create this secret before trying to proceed with this deployment. So I'm just going to pull up my terminal here and go ahead and create a secret. The warning is just from, I'm using Google Cloud and it's just giving me some FYI warning, so that's not relevant. But we can see here that the secret was in fact created. And then we have to come back and just rerun our pre-flight checks. So because they failed, we had already collected and analyzed the information, but now we've gone and remediated that problem and we want to rerun the pre-flight checks in order to revalidate that and hopefully come up with a different outcome this time so that we can be more confident to proceed with the installation. So this will just take a sec, but in light of that secret getting created, I would expect the first analyzer about the secret to pass. Obviously, I'll still have the warning on the Kubernetes version, but it's still an acceptable Kubernetes version, so I can roll with that, and I'm fine with that. So I should, at this point, be good to install my application, which is great. So I could come out here, and then from the dashboard with warnings, and go ahead and deploy this version. And everything's hunky-dory because I identified a problem early, went about remediating that problem because we had clear instructions on what needed to be there, and we could have linked to documentation if we'd wanted to. And now, as a result of that, I'm able to deploy this application with greater success against that problem and figure out what was wrong in the first place. So coming back, I just want to recap a couple of things and then mention one or two other things here. So to customize App Preflights, there's a bunch of collectors and analyzers to choose from, which if we have time, I'll show those at the end. And plus, you can contribute more. So Troubleshoot.sh is the open source project that this is all built on. That's an open source project, so you can go and contribute any collectors and analyzers that you want that would be relevant for your situation and make that happen as well. We've got the different outcomes. We can pass, warn, or fail based on different conditions, and we can add that unique messaging and link out to documentation or whatever sites we might want to. And then two other things that I haven't highlighted yet that I'll mention is you can actually exclude pre-flights under certain conditions. So a good example of this is, let's say a customer has a certain license entitlement. Let's say they're licensed to a premium edition of your software, so additional stuff is going to get deployed that needs its own pre-flight checks. You can actually condition those pre-flights so that they'll only run when a customer has the correct entitlement, and they'll get excluded otherwise so that they don't run unnecessarily. And then a new feature I want to highlight is requiring that pre-flights do not fail. So this is something that we're calling strict pre-flight checks. And to provide a little bit of background on why this is necessary, pre-flight check failures don't normally block a deployment within the admin console. So users are encouraged to remediate that problem, and they have to confirm that they want to deploy anyway past a failure, but they're able to do that if they wish to. And so sometimes the software vendor just knows that their application can't possibly run unless a certain condition is met. And so they really want that condition to be blocking and required in order to proceed with the installation. And so that's what strict pre-flight checks were designed to do. The way to make this work, and I'll show this in the demo in a moment, is including the strict field on an analyzer and setting it to true. And this just indicates that an analyzer must not fail. It can pass, it can warn, but it cannot fail in order for the deployment to proceed. And the admin console is going to disallow installation of the software until no strict pre-flights result in a fail outcome. So obviously, if you get a failure, it has to be remediated. You've got to rerun the pre-flight checks, and then you'll be able to proceed with the deployment. So let's take a look at this as well. So going back to to the vendor portal, I have a second release here that we can look at. We've got Preflight. So in this case, I've pared down my Preflight and just cut out one of the checks for the sake of time and ease here. And I'm just honed in on the cluster version. So we can see here that I've set strict true on this cluster version analyzer, which means this one cannot fail. And my outcomes have changed so that now I'm going to fail anytime I'm less than 1.23. So any Kubernetes version under 1.23 is going to fail, and not just fail, but the admin console is actually going to prevent me from proceeding with a deployment if that's the case. And I'm only going to be able to pass if I've got Kubernetes 1.23 or later in the environment. So I'm going to go ahead and promote this release to the stable channel here and go over and check for updates. So I can pull in this new version to my admin console. It'll just take a second for that to get set up, but Preflight checks run automatically when a new version is pulled in. So those are just going to kick off, and I've got to wait a second, but we can imagine what's going to happen already because I said I've got Kubernetes 1.22 deployed here. So given that we're checking for 1.23, I shouldn't be able to install this version until I upgrade Kubernetes. And we can actually already see this because the deploy button is grayed out and actually says that because there's a strict analyzer that hasn't been run yet, I can't actually deploy this version. So I've got to wait for Preflight checks to finish. And then even once they finish, because of the fact that I failed, this button is still grayed out. And I would have to come in, I would have to remediate this Kubernetes problem in order to deploy this application, because this is a check that cannot fail. So that's a relatively new feature, just to be able to actually block on preflights. I think that Amber alluded to that in her talk during the introduction to this, the keynote, but that's relatively new to actually prevent you from being able to continue in the event of a failing preflight. So now I want to touch on host preflight checks as well. So the goal of these is very similar, but instead it's to codify the infrastructure requirements so that everything that's needed to run Kubernetes is verified before Kubernetes is installed. And what some people also use this for is to optionally kind of front load some of their application requirements so that users can get faster feedback. So if you know Kubernetes needs 4 CPUs, but your application needs 8 CPUs, there's no reason to install Kubernetes on a 4-core machine and then wait all the way till the app preflights to decide, oh, here's a preflight check, you need 8 CPUs. So some people are actually using host preflights to front load some of their application requirements as well, so that they can detect that more quickly and prevent people from wasting their time installing Kubernetes on a machine that isn't going to support their application. So there's default host preflights that run obviously by default, and these are defined by us at Replicated for what we think is required for running Kubernetes and the add-ons that are included in the installer. And these can either be ignored, they can be disabled, added to, fully customized. I'll get to this in a moment, but there's a ton that you can do to change this up despite having some defaults. So by default, failures prevent an installation of Kubernetes, but we have a flag called host preflight ignore that can be used to ignore failures and proceed anyway, despite the failures. You can also enforce warnings. So if it's important that a warning fails, you can use the host preflight enforce warnings flag to prevent you from proceeding if there are warnings. And so there's different ways that you can customize what's actually going to prevent that installation from occurring. And ultimately, you can add host preflights to your Kubernetes installer. You can also disable the defaults with exclude built-in host preflights and setting that to true. And ultimately, putting these two things together yields 3 options. You can disable them all together. You can run the defaults in addition to custom ones that you define, or you can disable the defaults and just run an entirely custom suite of host preflights. And I'm going to show this in the demonstration as well to make it a bit more clear. So back in the vendor portal, I go to my Kubernetes installer tab, and let's look at just a basic Kubernetes installer. So in this case, I've just included just a basic set of add-ons that I need to deploy a cluster. I've got a container runtime in Kubernetes, I've got COTS, I've got networking stuff, storage, etc. But this should be kind of a basic cluster. And if I went ahead and just ran this as is, and because it takes a little bit of time, I've just done this in advance and we can look at the output. But I ran my install command up here at the top. We downloaded all the packages for all those add-on versions that we need. And then we can see that the host preflights immediately start running. So these are obviously the defaults because I didn't define any specific host preflights. These are just the default host preflights that are going to run. We're going to run our collector phase first. So all of these are our collectors for some TCP port statuses, CPU, memory, block devices, etc. There's add-on specific stuff. So I had the Weave add-on, I had the Longhorn add-on. So there's also checks that are specific to some of the add-ons that I included. And then ultimately, we can see the results of all of these host preflights here at the bottom. So these are the results produced from our analyzers. And just scanning this real quick, I've passed all of these checks. So host preflight success, and the installation would continue from here. So this was just kind of the basic defaults that run. But obviously, these are, like I mentioned, very customizable. So we can change that up instead. And that's what I want to spend a little bit more time referencing before we shift into questions here. So looking at my next installer that I created, from here up, it's identical. But what I've done is I've added a curl section here and then specified 4 new fields. So first, exclude built-in host preflights is true. So this says disable all the defaults and don't run them at all. Then I set host preflight ignore to false. That's the default, but I just wanted to specify it for awareness. So if you wanted to make the preflights never block an installation, you could set this to true. Same thing with host preflight force warnings. The warnings aren't going to block by default, but if you wanted them to block, you could set this to true to accomplish that. And then finally, I get to the customization where I actually have a host preflight spec that I can just drop in here to define what host preflights I want to run as part of this installation. In this case, I'm running 2 of them. So I've got a collector to see if I can access google.com, just picked a random URL for the sake of demonstration. And I have an HTTP analyzer down here that just says, all right, if we get an error, then we warn and print out that error. We're going to pass if the status code is 200, so we successfully connected, or in any other event, I don't know what happened, so we'll just warn that we had an unexpected response. And then we've also got a CPU check. So by default, curl, the Kubernetes installer, checks for 4 cores. But let's say my application is more compute intensive. So I want to fail if I've got less than 6. I want to warn if I have less than 8. And then if I've got more than 8, then we're good to go. So I saved this, I promoted this to my channel, and then reran it. And if I scroll down here a little bit, I can find this as well. So in this case, we re-downloaded the packages. They were all present, so we didn't have to. And then running host preflights, we can see it's much shorter because we only ran the ones that I specified because I disabled the defaults. We passed the we ran the CPU one, we ran the Google one, but I failed the number of CPU check because I had less than 6 cores. I have 4 cores on this machine, which actually blocked the installation and prevented it from proceeding. And that was because I didn't set host preflight ignore to true, so the failures are in fact blocking. But ultimately, all of that is customizable. What you want to fail, what you want to warn, whether those should be blocking is totally up to you as you define your host preflights spec. So I'm just going to return here for just a quick summary of what we talked about, and then we can shift into questions. So we talked about preflight checks, how they can increase installation success by making sure that your requirements are met before an installation occurs. We've got the 2 types, the host preflights for Kubernetes, the app preflights for your application. And then we have full customizability. So determine the criteria for which we pass, warn, or fail, add custom messaging and links, determine whether the preflight failures are going to be blocking or not. And then for host preflights, we can even stick with defaults, adjust them, or completely overhaul them. So in conclusion, for software vendors who are installing Kubernetes or their application into a customer environment, preflight checks are a really vital part of that process because they can really increase installation success by codifying all those requirements into a single spec, running that in advance of the installation, and giving your users feedback to make sure that they remediate any problems before actually attempting the installation. So awesome, that's the end of the demo and the presentation. Haven't seen any questions in the chat yet, but would love to open it up to any questions that anybody here has as well. So feel free, we've got a couple minutes left here. Feel free to shoot.
Is the Kubernetes, the host preflight checks, is that only for curl, like bring your own, like the embedded install, or can that work for existing customer installs as well?
It is only for the Kubernetes installer for curl at this point. There's a number of similarities between the host preflights and the app preflights. So like if you're wanting to check the amount of CPU or memory or things like that, those preflights exist within host preflights and app preflights. So there is overlap where you can accomplish different things, but the host preflights themselves are built into curl and run before the Kubernetes installer. So it is specific to that. Got it.
Yeah, I think where we run into trouble is customers have their own installation. Like one customer is using, I forgot, it was a Kubernetes distribution. The whole thing was based on a farm. All these like farm analogies. I think it's called Rancher.
Right. Yep.
And the person didn't have like the correct roles. And then like when we tried to do the upload the air gap bundle in the COTS screen, it just like hung forever. And it was this big investigation, and finally figured out that like there was some sort of role issue. RBAC issue, and then that was like the problem. And I guess like as a customer, like I would request that like CPUs and memory is like never the issue. It's usually like some sort of customer specific RBAC or CRD or something like that that doesn't work, and it'd be great to identify that before we ever even install COTS.
Right, that makes a lot of sense. I think we're about to get kicked out in 4 seconds, but feel free to send me a message